On paper, the partnership looked unbreakable. 13 years of shared blueprints, shared factory floors, two company names stamped side by side on the same locomotive nameplate. Then, General Electric packed up its half of the operation and walked away. The company left behind was the American Locomotive Company, Alco, to the men who ran it. Alco spent the next 20 years proving General Electric wrong, and it lost anyway. Have you ever watched a company get blamed for a mistake it had already fixed? Tell us in the comments below. Subscribe to American Iron Works. We dig up the industrial stories the history books buried. Before any of that, Alco was untouchable. The American Locomotive Company built more than 75,000 locomotives between 1901 and 1969. Alco built the Union Pacific Big Boy, the heaviest steam locomotive ever put on rails, weighing over 1.2 million pounds with its tender. During World War II, Alco's Schenectady plant built 7,362 Army tanks and 3,314 M7 tank destroyers. Its M7s rolled straight into the rout of Rommel's forces at El Alamein. Between 1941 and 1945, Alco's output grew from $22,358 a year to more than $428 million, an increase of over 1,800% in 4 years. The plant that built that many tanks, that fast, was not staffed by amateurs. In 1924, Alco, General Electric, and Ingersoll Rand built one of the first commercially successful diesel-electric locomotives in North America. That was 11 years before Electromotive, the company that would eventually beat Alco into the ground, even had a diesel road locomotive on the market. Alco had the head start, the reputation, and a century of proof standing behind both. The Delaware and Hudson Railroad, the New York Central, and the Union Pacific all favored Alco equipment for decades running. Alco's business ran on that kind of customer loyalty, built over generations. Railroads ordered from Alco because their fathers had ordered from Alco. Locomotives came custom-built, one design tailored to one railroad's specific grades and curves. Alco had no dedicated national sales force, and for decades it didn't need one. Then, in 1935, Electromotive entered the diesel locomotive business. Alco's diesel market share fell from 83% to 23% in a single year. Alco's president at the time, William Dickerman, was not worried. In 1938, he told the Western Railway Club that steam's technical potential was still wide open, while diesel's possibilities were already fixed and known. He was an engineer with a degree to prove it. He was also about to be wrong twice. Electromotive was not run by engineers. It borrowed its playbook from the auto industry with standardized parts, a dedicated marketing division, and an advertising campaign called Men Who Build the Future of American Railroads, which put railroad executives' own portraits on the cover of the industry's leading trade journal. Alco's 1946 product premiere in New York featured a tribal dance performance and a free carnation for every visiting executive. Neither company thought it was choosing between engineering and salesmanship. Only one of them was right about which one mattered more. By 1944, with the war nearly finished, Alco's leadership set out to close the gap fast. Engineers got one order: build a new engine capable of beating Electromotive's 567 engine to market, and do it by the end of 1946. That deadline is the whole story in miniature. Alco had survived on speed before. Speed built the tanks on schedule during wartime steel shortages. Speed was the thing Alco did better than almost anyone in American industry. This time, speed cut the wrong corner. The new engine, designated the 244, went from first drawing to first production locomotive in about 18 months. Normal engine development, even in the 1940s, took 5 to 6 years. The men racing that deadline didn't know the shortcut would cost them the very reputation the deadline was built to protect. Each 244 engine block weighed close to 8,000 pounds, about the weight of 2 loaded pickup trucks stacked on top of each other. That much cast iron does not forgive a rushed weld, and the welds were rushed. Investigators later traced Alco's field failures to 2 specific causes: metallurgical flaws in crankshaft forgings, bought from an outside supplier, and defective welds joining the main bearing saddles to the engine block itself. Roughly 600 of those blocks needed their bearing saddles replaced. The 244's turbocharger forces extra air into each cylinder, letting the engine burn more fuel per stroke and produce more horsepower for its size. The exhaust gases spinning that turbocharger run hotter than a kitchen oven set to its highest temperature, cycling through that heat thousands of times a day. Alco redesigned the turbocharger assembly twice, in versions labeled 244D and then 244G, before the underlying engine was retired. By early 1948, Alco had spent $4.3 million on field repairs to an engine that was supposed to save the company. Alco's own senior vice president, Joseph Ennis, told the trade press in late 1945 that the future holds an expanding role for the steam locomotive. Alco built its last steam locomotive 3 years later in 1948. Robert McCall, elected Alco's president that same December, had trained as an apprentice draftsman on steam engines in England. He had never run a diesel engineering program in his life. For 13 years, General Electric had supplied the electrical components and shared the sales floor under the Alco GE badge. GE also had its own gas turbine locomotive program running quietly alongside the diesel work. In 1953, dissatisfied with how long Alco was taking to fix the 244, GE ended the arrangement and took that turbine program with it, walking away with the very technology that would let it become a locomotive builder in its own right. 2 years after that split, an internal GE marketing report put the damage in writing. The stigma of unreliability, the report stated, is still following Alco and damaging their reputation and ours. Alco was not out of engineers who understood the problem. It was out of time to promote the one who did. Perry Egbert had run Alco's diesel engine development program since 1929 with a mechanical engineering degree from Cornell. For 10 of those years, Alco's steam-trained leadership moved him into a sales manager role instead, work that kept him employed but kept his engineering judgment off the executive floor. He did not become Alco's president until December 1952, 19 years after he first understood exactly what was wrong. Under Egbert, Alco's engineers threw out the 244 and started over. The new design, called the 251, used nitrided crankshafts hardened against the exact fatigue cracking that killed the old one. Turbocharging was built in from the first drawing, not bolted on as an afterthought. The 251 entered production in 1956, and it worked. 70 years later, under the Fairbanks-Morse badge, that same engine design is still being manufactured. The engine that could have saved the company took 12 years to design, start to finish. The deadline that nearly buried the company's reputation took 18 months. Somewhere in Schenectady, somebody should have swapped those two schedules. That engine still runs today, 7 decades later. Knowing it worked all along, does that make what happened next more infuriating or less surprising? There is a detail almost nobody puts in this story. Electromotive, the company crushing Alco in every sales column, never actually tried to take 100% of the market. Federal antitrust regulators were already watching General Motors by the 1950s, and EMD's own executives knew total dominance invited a breakup order. Alco survived as long as it did, partly because its biggest competitor found it more useful alive, as a hedge against the government, than dead. The timing worked against Egbert's fix in one more way. By 1956, the dieselization boom that had driven American railroads to replace steam all at once was already slowing down. Electromotive's GP9, backed by a nationwide service network Alco had lost when General Electric walked away in 1953, was already the proven default. Being right came too late to matter to the sales numbers. Alco's diesel market share had peaked at 26% in 1946. By 1966, it was 11.5%. By 1968, it was 2.6%. The company-wide numbers tell the same story from a different angle. Alco's locomotive sales revenue fell from $131 million in 1951 to $26 million in 1954. Total company earnings dropped 92% between 1955 and 1961. Schenectady's workforce, which had stood at 10,000 people in 1951, was down to 2,000 by 1960. In 1917, Alco had ranked as the 52nd largest industrial corporation in the United States. By 1948, it had fallen to 145th. Electromotive's own return on investment averaged 55% a year through the 1950s. Alco's averaged 2%, and the company lost money outright in 4 of those years. Alco's answer was the Century Series, launched in 1963, chasing raw horsepower instead of a fixed reputation. Its flagship, the C630, produced 3,600 horsepower, enough pulling force to start a fully loaded freight train weighing more than 3,000 tons from a dead stop on level track, roughly the weight of 1,500 loaded pickup trucks moving together at once. It was the most powerful single diesel locomotive built anywhere in the world at that time. Horsepower did not fix the sales numbers. The C400 line sold 297 units. The C600 line sold 348. Electromotive's competing SD40, introduced in 1966 alone, sold 1,257. In December 1964, the Worthington Corporation bought Alco outright. 3 years later, Worthington merged with the Studebaker Corporation to form Studebaker-Worthington Incorporated. In January 1969, the new company's board installed a Yale Law School graduate named Darold Ruttenberg as president and chief executive officer. Ruttenberg had never built a locomotive, sold one, or worked a single shift on a factory floor. He held a business degree from Harvard. He built his career buying struggling industrial companies with borrowed money, a method later generations of Wall Street would call a leveraged buyout. He had arranged the Studebaker-Worthington merger himself 2 years earlier and avoided publicity throughout his career. Alco was simply the next asset on a spreadsheet he had built to hold many assets, not just one. Ruttenberg demanded 25 to 30% returns from every division under Studebaker-Worthington's roof. Alco's locomotive business, capital-heavy and cyclical by nature, could not deliver that number in a good decade, let alone in 1969. The Alco Products Locomotive Division was the first unit Ruttenberg eliminated. Alco's own president at the time, Edward Forbes, told the Schenectady Gazette the shutdown was about a highly depressed locomotive market. Sales had fallen under 1,000 units nationwide that year, down from roughly 4,500 a year at the industry's peak. That explanation is true. It is also incomplete. Historians who have studied Alco's full financial records still disagree. Some say a market downturn alone would have closed the plant. Others say the 25 to 30% return demand made the outcome inevitable the moment Ruttenberg took the job. The paper trail supports both readings, and neither side has ever fully won the argument. On January 8th and January 10th, 1969, 2 T6 switcher locomotives rolled out of the Schenectady Works for the Newburgh and South Shore Railway. Construction numbers 1016 and 1017. They were the last locomotives Alco ever built, rolling off the same Schenectady floor where the company's first engine had been assembled generations earlier. 121 years of continuous locomotive production at that plant ended with them. The same trait built Alco and broke it. 11 years before Electromotive existed, that instinct gave Alco its diesel head start. During the war, it built tanks on a deadline with steel already rationed. After the war, the same appetite for speed rushed the 244 past the testing it needed. And in 1969, a different kind of speed, a boardroom return on investment clock instead of an assembly line, gave a new president the confidence to close the plant within months of walking through the door. The company that moved fast enough to help win a world war could not survive the version of speed that finance runs on. The 251 engine is still running today. In locomotives, most of the men who designed it never lived to see retired. Somewhere, a Fairbanks-Morse technician can still pull a parts order using a serial number stamped in Schenectady before Ruttenberg ever set foot in the building. The metal outlasted the verdict against it. It just didn't outlast the company that built it. If this is the kind of story you want more of, subscribe to American Iron Works.